Good morning to one and all present here. In this video, we are going to see about an informed search method which is based upon the actual as well as the heuristic cost, okay, for finding the best path. So now, first we have to go on with the difference between what is an informed and what is an uninformed search in AI. Informed search is one which will be informed or which will know about the information on the knowledge of or about the problem. There's something called as heuristic value. Uninformed doesn't have that particular information. So informed search method stands upper hand over the uninformed search methodology. So, out of the informed search methodology, such as greedy search, which is called as best first search, and A star algorithm, we are going to see the best informed search methodology, that is A star algorithm. Now, what is this A star algorithm all about? The A star algorithm is one which is the most widely used informed search algorithm. It is used in finding the shortest or least path or cost path from particular initial node to the end or goal node by actually including the actual cost and the estimated cost. And it is unlike uninformed search algorithm. This A star uses heuristic information that is called as the knowledge based information about the problem, which would guide this A star to make the search efficiently while it traverses from one node to another. How does this A star algorithm works? Basically, A star algorithm makes the progression of moving from one node to another node by evaluating a value called f of n, which is the possible path, okay, value, evaluating the possible path value by using two more value, which is called as g of n and h of n. What is this g of n tells about? The g of n is the actual cost from the start node to the current node traversed. And what is h of n? H of n is nothing but, which is an estimated cost or knowledge based cost, or I can just say that as a heuristic cost from the current node in order to reach the goal node. So ultimately, by adding this f of n along the for obtaining this f of n, adding g of n which with h of n, this f of n has to be the lowest value. So accordingly, traversing from one node to another takes place, ultimately reaching the goal node. So here is a small problem which is given to tell how this A star works on. So now the starting node is A, the ending node is E, and the g of n from A to C is given as 1, and A to B is given as 2, from C to D is given as 1, from D to E is given as 1, and from B to E is given as 3. And obviously it has to need some heuristic values. The heuristic values of A, B, C and D are given as 2 and E is given as 0. So ultimately, when I just make the problem to work with A star algorithm, the starting node is given as A, where the A node is connected to two more nodes B and C. Now I have to find the f of n value which would be the g of n plus h of n. So f of n for reaching from A to C and f of n from reaching from A to B. So if it is from A to C, it is 1 plus C has the heuristic value of 2, so it is 3. So if it is from A to B, the g of n is 2 and b has 2, so it is 4. So f of n for reaching b is 4 and f of n for reaching c is 3. So ultimately the f of n which is lowest will be chosen. So the chosen node will be A to C. So C is coming to the closed and B is in open list. Now C is connected to D. You don't have any other node. So now the f of n will be 1 plus 1, that is g of n, plus h of n, d is 2. So 2 plus 2 is 4. So now D node is going to the closed. Next to the D is connected. So g of n is 1 plus 1 plus 1, 3, and E has h of n is 0. So now the f of n is 3, which is the least. With this, it will not stop because already B is an open list. So it will also try to find what is the f of n when the path is from A, B, and E. So 2 plus 3 is 5, 5 plus 0 is 5. So ultimately, when I just start from A, C, D, and E, I have the value of f of n is 3, and from A, B, and E, it gives a value of 5. So ultimate, the goal is reached, okay, when we travel from A, C, D, and E. That is what is your A star algorithm. So in order to uh, make the problem to be more understandable, let me just take a complex graph where I have to start from S and reach to G by traversing through so many nodes that are being given as A, B, C, D, E, F, G, H, I, and K for reaching the goal G. Now, when I see this problem here, I have S node connected to node A, B, and C. So now S node is going into the closed list. Okay, S node is going into the closed list. Now the S is connected to A, B, and C. So A, B, C will be in the open list. For the open list, I have to calculate what is the f of n. The f of n in the open list will be made by adding the g of n and h of n. So g of n from traveling from S to A would be 4 and the h of n is given as 8. So 4 plus 8 is 12. So f of n for A from the starting node S is 12. So from S to B is, this is 10 plus 6, 16. So f of n is 16. Again from S to C is 11 plus 5, so 16. So out of the ABC, the f of n for A is least. So A will go to the closed list. So A go to the closed list, right? And B and C remain in the open list. Now I have two nodes B and D connected to A. So when I just go on for B and D nodes connected to A, again I have to calculate what is the f of n. Now the f of n is g of n plus h of n. Now the g of n will be nothing but 4 plus 5 for reaching D, and h will be 5. So 4 plus 5 is 9. 9 plus 5 is 14. So D has 14. So it comes up in the open list because already existing B and C has 16. The next one is B. So 4 plus 8 plus 6. So 4 plus 8 is 12. 12 plus 6 is 18. So again B is given as 18, that comes to the last in the open list. So now the least in the open list is D, right? Where D has 9 plus 5, that is 14. So D is taken into the closed list, right? Now D is D is connected to three nodes H, I and F. Now calculate the f of n for traversing from D to H, D to I and D to F. So the path where S A D H, S A D I, S A D F. So the f of n cost adding g of n and h of n for reaching h through D is 4 plus 5, 9, right? 9 plus 16 is 25. 25 plus 7 is 32. So for H, it is f of n is 32. That goes to the last in your open list. Now next for reaching I, it is 4 plus 5, 9. 9 plus 20 is 29. And 29 plus 4 is 33. So it goes before H. Next to F, it is 4 plus 5, 9. 9 plus 1 is 10. 10 plus 3 is 13. So F goes in the first of the open list. So what happens is F is the least f of n value. So now after A, B, D in the closed list, F is having the least f of n, so F will be just taken to the closed list. Now, from F, the only node that is being connected is G. So now I have to calculate what is the f of n. Now the f of n for this is 4 plus 5, 9. 9 plus 1 is 10. 10 plus 1 is 10 plus 13 is 23, and 23 g of n plus h of n 0 is 23. So from traversing to from S to G through F, it is 23. Okay, so now the 23 is the least one. But this A star algorithm doesn't stop with this. After taking F to the closed node, which has the uh, uh, next node to be only G, which has G to the closed node as the path comes as SADFG, being 23 is the least, it doesn't stop. Why? There are other nodes that are in the open list. So the A star algorithm goes on for the calculation of the other nodes. Okay. Though 23 is the least, we don't stop with that. We'll just go on for other closing of the node in the list according to the least f of n. So again, we will just go to the node C, okay, and we will just try with the nodes that are being connected to C as D, E, and F, and go on in calculating the path value by calculating the f of n as g of n and h of n. Now ultimately, on seeing all the path value, now while I just take the node as C, S, C, F, G, that gives 26. Okay. Similarly, S, A, D, F, G is 23.